Let's face it, hiring help is not easy these days. Let XenTegra Staffing help you find the right person for the right job. Head over to XenTegra.com/XenTegra Staffing to find out more and let us staff your people needs. Welcome to another Citrix Session with your host, Andy Whiteside and Bill Sutton, your source for all things Citrix.
All right. Hello, welcome everyone. I'm Andy Whiteside. I'm your host for today's The Citrix Session podcast. Today we're going to be talking about a very interesting topic for me, and I'm going to learn a lot because this is not something I know a whole lot about. Of course, I've got with me Bill Sutton, the Director of Services at XenTegra. Bill, how's it going?
Going well, Andy, and I would echo what you just said. I'm hoping to learn something myself, as this is not a subject I know much about either.
Yeah, I'm excited about it. I'll go ahead and add a little bit more color to that. I read a blog one time where somebody had a conversation about Kubernetes, and they said they knew less about it. It was an hour-long presentation they went through, and they felt like they knew less about it after the presentation than they knew before they started. And, that's kind of how I've been feeling about the topic as well. So hopefully we'll straighten that out here today.
Yep.
And learn how that fits into the Citrix world. The topic of the blog that we're reviewing from April 1st is Citrix ADC for Kubernetes, scaling DNS with CPX as node local cache. So that's we're definitely going to get technical in this one. We also have with us from the XenTegra side, Chris Doran. Chris, as of the first of the year, started leading our networking practice. Chris has been a long-time consultant at XenTegra and has taken over the reins of running our networking practice, which includes a heavy dose of Citrix networking around ADC as well as SD-WAN. Chris, welcome.
Thank you very much. Excited to be here.
So Chris, this is your first podcast with us, right?
I was in when we had the exploit. I hopped in one to chat about it a little bit too, but yes, one and a half here.
Well, I'll try to make sure we keep you in the loop on all the networking related ones, because obviously you'll add a bit of color to that Bill and I are lacking. So I'll try to do a better job of getting you involved going forward.
Thank you.
And then from the Citrix team, we have the author of the blog, Raghav. Raghav, how's it going?
Going on good.
And your title is Principal Software Engineer at Citrix. And Raghav, you want to give us just a little background on your Citrix story?
Yes. Hi, I'm Raghav, working in traffic management team, and I'm with Citrix for the past 15 years. So I mainly work on LB, GSLB, and the surrounding areas.
No, that's great.
Yeah.
So obviously the GSLB is going to tie right into our DNS story we're going to talk about here, right?
That's correct.
All right. Well, welcome. I know you've got a team of folks with you. Do you want to introduce them now, or you want to just kind of call on them as we start going through this?
Yes. In the call, I have Vinay, who actually developed this feature with me, and from the product management, we have Komal and Miko, and our chief architect of Cloud Native, we have Chiradeep as well.
Okay, great. Hey, maybe we should start by giving us your 30-second description of what Kubernetes is all about.
Okay, so can you make me the presenter?
Well,
I have a presentation.
Well, no, I really just want like a 30-second explanation of what Kubernetes is. We're going to focus on the blog, right? We're going to go through the blog, but we probably should help some of our listeners understand what Kubernetes is. And they can't see this, right? It's an audio blog, so they won't see the presentation.
Okay, so basically Kubernetes is mainly a container management platform which is widely deployed across enterprises, and it enables faster deployment of applications, and also it helps in scaling the applications in a smoother fashion.
So I think one of the ways I look at Kubernetes and containerization, right, it's like having well, in your case, maybe a cricket team, but here, a football team, and each person has a role that they by themselves could go do that. And in the case of Kubernetes and containers, we've gotten to a world where, we're just having a kicking competition and all we got to do is kick. So, in this case, like we're going to talk about here, maybe there's a DNS need that maybe we just have a DNS role that's being played by a service. And we don't have to have the entire team. Does that make sense to you? That makes a fair description of what Kubernetes is?
Yeah.
Okay, great. Bill, did my Andyism I just used make sense to you?
It absolutely did. Of course, I was thinking of a different type of sport, but that's just my preference. So, same difference.
Yeah, I think the thing I like about my analogies or metaphor, whatever that one was, you literally could have just a kicking competition and not need the rest of the team if that's all you wanted to do was have a competition around kicking.
Correct. I agree.
Which at this point in time, with so little sports on, maybe that would be a pretty good idea. Yeah. All right. Hey, Chris, anything else you want to add before we start jumping into the blog?
No, I'd love to hear it. I haven't read through the whole blog myself, but yes, to reinforce what you're stating, the Kubernetes world, the more you investigate in it, the more you can feel like you're at a loss and trying to play catch up with some of the terms and services that we can conduct on it. So looking forward to this.
So Raga, do you want to maybe go through the introduction section here and tell us what you're covering?
Yes. So I'll just start off. And so in general, whenever an application is being moved from a monolithic architecture to a microservice, so there will be a lot of surprises during this transition. And one of the key elements of a microservice architecture is the service discovery. And DNS is one of the common ways of performing this service discovery. The service discovery includes actually discovering the IP address of the microservice that you're trying to communicate with. So now in the monolithic architecture, what used to be a process in a virtual machine, now it's categorized as a microservice, and it needs to be accessed through a service discovery, that is a DNS. So now every such communication between the microservice will result in a call to DNS. As a result of this, there will be a steep increase in the DNS, in the call to DNS function as compared to monolithic architecture. So, and this would be one of the earliest challenges that one would face during their transition from a monolithic to microservice architecture. And the problem would be more pronounced as the application scales. That is, when I say scale, where the number of containers of a microservices increases, scale up as part of the autoscale function.
So in this case, you're saying that a new application that's part of a microservice is going to generate net new activity that's going to impact the traditional, let's say, DNS in this case. And so being able to provide DNS as part of that microservice, that's really what our angle is. Is that a fair synopsis?
I mean, currently the DNS is by default provided by the Kubernetes platform. So we are just trying to augment it by providing a layer of cache. I'll just come to that. So the DNS is by default provided by Kubernetes. That's in the latest Kubernetes release, the core DNS is the default DNS implementation that comes baked into the Kubernetes platform itself.
Yeah. So what you're doing here then is the ADC is providing that more intelligent, more efficiently, and better. That's what we're really talking about then, right?
That's correct.
Cool. Hey, Chris Thorne, any thoughts or comments on that as part of the introduction there? That was great.
No, it seems like it'll help a lot.
For the Citrix team, are you guys seeing a large uptick in using containerization, and that's why the Citrix story around ADC is evolving to be part of that?
Miko, Komal, do you want to take that question? Or Chiradeep?
I'll take it if nobody will. Yeah, no, we are seeing an uptick in containerization in our customer base. As we have some customers already made the migration in 2019, some in 2018, and we're seeing more of them happening this year. And and this is consistent with what Gartner and other analysts have explained to us.
Yes.
Is this across all verticals of business, or are you seeing it more in financial or healthcare? Maybe you can.
I think you've nailed it there, right? So we see definitely in those two verticals, they are making the transition. And in the case of financial, some of them already in levels of production, but we're in early stages here, and this is a long-term transition, of which financial and healthcare have made the first transition. But there are other places like we're seeing it now in retail, for example. And so I expect this, and utilities, telco. So I expect this will be it will touch all verticals in time.
Okay.
Yeah, if I may just add to that. So I think it starts with everybody want to go faster, and that's usually part of their digital transformation. And so then they look at the best practices from the industry and they say, well, everybody's moving to microservices. Well, if you say I'm going to do microservices, well, then what's my platform for that? And the de facto platform today is Kubernetes. And so any industry that's going through this digital transformation, moving to edge, is adopting Kubernetes. So it's huge.
Yeah. So, guys, do you want to jump into the how to scale the DNS layer, the article?
Yeah, sure. And thanks, Chiradeep, Miko, for chipping in. So actually, a lot of engineering organizations have blogged about this, and even in KubeCon, they had discussed about this, about the issue with scaling the DNS layer. So, and just as an introduction for guys who don't know about NetScaler or Citrix ADC currently, we have a very strong DNS, our own native DNS implementation, and which has good performance numbers. So, and this is an attempt to bring in or how to use this performance in the cloud native deployments as well to solve some of the existing issues in Kubernetes. So, okay, I think general workflow is whenever a microservice tries to access another microservice, it's preceded by a call to DNS server. That would be the core DNS in case of Kubernetes. So, and so now what happens is now that generally there will be like hundreds of thousands of microservices in any deployments. So all these thousands of microservices will be coming to this core DNS servers to resolve their domain names. So as a result of this, the core DNS gets choked, and due to some inherent issues in the Kubernetes and some of the race conditions that exist currently, it leads to some latencies and some drops. And as a result, the application will be facing timeouts or in general degradation in their quality of service. So in DNS in general, irrespective of whether it is cloud native deployment or otherwise, caching is used predominantly to offload the DNS server from excess load. The same is being used here as well. The concept is the same. And in DNS, each DNS record, the DNS record is an information in DNS. So generally, the most predominantly used DNS record is an address record or a foray record in case of IPv6. So now each such DNS record has a TTL value associated, that is the time to leave value associated with it, which actually tells or dictates as to how much till what time can the cache use the same record to serve its client without accessing the authoritative DNS server. So what we are doing is we are introducing a layer of cache in between the microservices and the authoritative core DNS server in the Kubernetes platform. So now what happens is whenever a microservice tries to resolve a domain name, it first hits the cache, and if the record being accessed is already there in the cache, it will be served. And if it is a cache miss, then only then it will be going to the backend core DNS server, which is by default provided by the Kubernetes platform. So now, and these cache server will be placed in each of the node in Kubernetes. In Kubernetes, there could be multiple nodes. So, and the cache will be local to each node. As a result, the latency will be very less, and as a result, most of the requests would be served from the cache itself. As a result, even the core DNS, backend core DNS server is offloaded, and the load is reduced. So this is in just what we are doing. So here for cache, we are using CPX, and this is a very popular design pattern that is being used by the community. It's called the node local cache, and Kubernetes also has this currently. So I'll come to the differentiators and how Citrix ADC is better in the later point of time. So currently, so we are using our CPX's DNS feature here to augment the DNS function in Kubernetes.
So let me interrupt real quick, and I'll let Bill and Chris jump in if they have a question. But the whole goal here is to get the DNS name resolution closer to the application so that the application performs better, correct?
That's correct.
Okay. Bill, Chris, either one of you guys have something you want to comment on here before we jump in?
So the CPX microservice is just another microservice within the node, right? That the other microservices are communicating with instead of going out to the core DNS server or microservice.
And that's correct. It's actually deployed as a daemon set. Okay. There is an entity called daemon set in Kubernetes, which is where an application instance will be deployed in each of the Kubernetes node.
Okay.
It will be a node-specific instance. So
I see.
It's installed as a daemon set.
Okay.
And guys, is it proactively going out to some authoritative DNS and caching the information, or it's just caching once it resolves something and keeps that resident? How does that work?
Sorry, can you repeat the question?
Is it going out and proactively caching what it can get from an authoritative DNS server, or is it just recognizing some type of resolution and keeping that in cache? Or is it doing both?
Actually, it's doing both. I'll just cover that as to why Citrix ADC and the proactive DNS cache update as well.
Sorry, I'm getting ahead of you. Sorry, I just got curious. Go ahead.
Chidati, do you want to add anything until this point?
No, I think that, as you said before, the microservices, it just amplifies the amount of chattiness that happens between applications. And ADC, as it turns out, is poised right there to reprise its role as a as a scaling agent, as a proxy, and as well as the DNS cache.
Okay, thanks, Citrix. So coming to the part as to why Citrix ADC CPX. So one of the key reasons for going with Citrix ADCs is the performance. And we have done extensive tests, and we have given the results of it in the blog as well. And Netscaler or Citrix ADC is very well known for its performance numbers and DNS and HTTP, or in general TCP SSL areas. So, and that is actually coming handy even in cloud native platforms as well. So that is a key advantage that the Citrix ADC has. And coming to other features which helps in improving the performance. The one is the proactive DNS cache update. So whenever we get the DNS request from the microservices, for the first time, if it is a cache miss, that's the record being queried. If it's not there in the cache, we'll go to the authoritative DNS server and fetch it and cache it. And if that cached record is frequently accessed, or if it's a hot object, then before it gets expired, we actually proactively go to the backend server or the core DNS server in this case, and fetch the record and keep the DNS record fresh, updated. So as a result of this, during the time of client's request, we would avoid going to the backend and in turn avoiding that additional latency. And it will in a way we are making sure that most of the times the DNS requests are served from the cache itself. So this is one of the key advantages. And thirdly, it's the DNS request switching. What do we mean by request switching? The pipeline DNS requests are very common in DNS. Pipeline DNS requests means where there are multiple DNS requests coming from the same client on the same port tuple. And in case of DNS, in case of Citrix ADC, if it is a cache miss, we'll be doing a load balancing at the request level. That is, if there are multiple core DNS server instances, the first request can land on server 1, and the second request coming on the same port tuple can land on server 2. As a result, it results in a more even load balancing of the core DNS server as well. So, and it's like improved usage, server usage. And as a result of cache and proactive DNS cache update, there is a reduced DNS latency, and we have a far superior numbers for various percentile numbers with CPX. So at the 99th percentile latency with CPX as a node local cache is around 793 microseconds. The same with core DNS is around 9,740 microseconds. And similarly, we have superior numbers with 95 and 90th percentile as well. And
Raghav, can you help me understand what you mean by percentile? I mean, I get the numbers and our listeners can't see the numbers. However, we can walk through them. But when you say 99 percentile,
so yeah, what it means is 99% of the DNS request that's being served by CPX has at max 793 microseconds latency. Whereas with core DNS, at max, 99% of the requests being served by the core DNS has around 9,740 microseconds latency.
Okay. Chris, Bill, any thoughts here?
It's an impressive improvement.
Yeah, it's the same thing I was going to say. Yeah.
Well, and that's the thing, right? When you're using an application, even if you're just for the layman person, right, when they're browsing the internet and they're blaming their bandwidth or they're blaming whatever they're blaming for why stuff's not running fast. They don't understand, there's a name resolution factor that goes into all this that can be optimized and should be optimized, but still has to happen. I have people all the time, they complain about their Wi-Fi. I'm like, yeah, it's not your Wi-Fi. Your Wi-Fi is fine. It's all the things that have to happen to get you to where you're going that you have no idea about. That is the real part of this. And there's a multi-step process, and DNS is one of them. It's just, at my house, all people know is the Wi-Fi. The Wi-Fi is the blame for everything.
So DNS is a precursor to any application access. If you see the numbers, if you use the core DNS as the node local cache, it's close to 10 milliseconds, the latency at the 99th percentile. So if you replace it with a CPX, it comes down to around 800 microseconds. So it's almost greater than 90% improvement. So there are two factors. One is the latency due to DNS, and also later on it's the application, the native application also has its own latency. So here we are talking about the latency due to DNS alone. So the latency due to DNS alone could be improved by more than 90% compared to core DNS as node local cache.
And when you're talking, millions and millions and millions of transactions, maybe a second, that's a big deal.
Yeah. Now, when you guys look at this in your scaling, is it better to scale up or out with this kind of platform in the size of the instances that you're provisioning?
Sorry, was it a question for me?
Yes.
Can you repeat it?
Like I look at the specifications on the specs of the CPX that you were testing with. If you were to add more into that environment, would it be more beneficial or recommended to scale up and assign more resources to that instance, the CPX instance, or would it be more beneficial to add additional nodes to the pools for the caching?
No, in theory, you can add more CPU to it, and there are no issues or no limitations as such, but it's always recommended to keep it lightweight, because DNS is just a auxiliary function, because there are other application instances which would require the major resources. So, since these instances are per node, I don't think so you should be seeing huge number of requests which can't be served by
a lightweight instance. Okay.
If you see such a scenario, you can increase it, but very unlikely though. We would like to keep this cache layer as light as possible.
Okay. Yeah, that answers my question. Thank you.
That's the beauty of the solution. It's so unobtrusive, almost automatic, and then it just supercharges your performance.
That's true.
With those differences in the time there between core DNS and cache DNS, that's like a deal breaker in some applications. That's night and day difference in that amount of time that we're seeing that's saved by caching. So it's very, very impressive numbers.
And another thing I want to highlight is the core DNS here, we are being referenced here in the percentile numbers, is the core DNS as the cache. Core DNS can also be used as an authoritative server, and by default, that is the authoritative server that would be used in Kubernetes platform. But here, the numbers are compared against when core DNS is installed as a node local cache, similar to CPX, so that we are comparing apples to apples.
Nice.
So if there is no caching at all, the improvements will be even steeper, but that would be a wrong comparison. So here we are sticking to core DNS as a cache.
Hey guys, the next section of the article talks about, why not a sidecar deployment? What are you guys trying to say there?
I think before that, I think Chiradeep had something to say. So
Sure.
Yeah. So the interesting thing about microservices or the inter-microservice communication is that these are not like one shot. So you can have, for instance, a front-end service called the shopping cart service. The shopping cart service called the catalog service. The catalog service called the search service. The search service calls the indexing service. And so a single call coming in from outside the microservices architecture can lead to this amplification of a number of calls. Now, if each of these calls is taking a worst case of 9 milliseconds, you can imagine that the end user experience is going to be terrible. And so by introducing this cache in between all these microservices, it improves the end user experience a lot. And that's something that Citrix cares about a lot.
Yeah, it just builds on the top of it, right? It just keeps,
Right, yeah.
just keeps one little, extra hop or extra second of latency on top of another, especially within an app architecture is going to culminate in additional latency. All right, guys. So yeah, the section where it says why not sidecar. What do you mean by sidecar, and what are you guys covering here?
yeah, sidecar is one of the deployment strategy that's being used where there will be a proxy attached to each of the application instances or the microservice instance, and some of the functions would be offloaded to the sidecar, and like the SSL and other functions like firewall or any such auxiliary functions would be offloaded to the proxy which comes attached to the application instance. And there could be an argument as to, hey, why can't we have the DNS cache as a sidecar deployment? That is where in the proxy that comes attached to the application, it can also act as a DNS cache. So here, when it comes to DNS cache, the DNS cache advantage comes only when the cache is used immensely. So if the cache needs to be, if the cache record needs to be used, it can't be that. It's very unlikely that the same application instance will try to resolve the same domain name multiple times, where it would lead to a cache hit. But it's very likely that a microservice being accessed, it can be, let's say, a DB or a logging server. Let's say there are like tens of microservices in an Kubernetes node. If all are trying to log their transaction into a log server, and they are trying to resolve this log server's domain name, so it's very likely that the first microservice instance which tries to log will try to resolve the domain name, and it would be cached in the node local cache, and all the other for the subsequent access to this log server by other microservices would be served from the cache itself. Whereas if you had gone with the sidecar deployment, each of these 10 microservices would resolve the DNS, the domain name of the log server independently, and it may not lead to a cache hit. So this will help node local cache will help in consolidating the DNS cache, and it improves the cache usage, and in turn reduces the latency, and the other advantages which comes along with the cache applies here as well.
Yeah. So you're working smart, not hard. You're also doing something I'm a big fan of, which is, why go discover for yourself how something works or what the answer is when I can introduce you to somebody who already knows.
That's correct.
Yeah. Hey, Bill, Chris, any other thoughts on this?
No, I'm good. It's very interesting, and like Chris said, that's a pretty significant improvement in performance leveraging the CPX the CPX architecture.
So Citrix team, bring us home on the conclusion on why this, this blog is relevant, and people in the Kubernetes world, the container world, should be, looking at NetScaler to take care of this piece of the equation.
Yeah, so DNS is like the first thing which any application access. Before any application access, the DNS would be the first function to be performed. So it's always better to have this DNS layer with reduced latency and reduced timeouts, so that you can guarantee a particular quality of service to the application users. So by having a node local cache, you'll be able to reduce the time taken for these DNS resolution, and also it reduces the number of DNS failures, which in turn improves the user experience with your application. And this brings in the Citrix ADC performance advantage to Kubernetes as well.
Right.
So, Chiradeep, do you want to add anything else?
No, I don't have anything to add.
Then I guess the alternative is we just tell everybody in every application code IP addresses, right? Is that? So guys, I appreciate it. This is just another example of where the Citrix ADC solution is adding value and services that most people, historical Citrix folks aren't thinking about beyond, gateway ICA type of conversation. There's a ton of stuff you can do with a Citrix ADC, aka NetScaler, and this is just another example of how this platform is going to continue into the future to evolve and to help applications run better and more secure. So guys, I guess with that, any additional comments before we wrap up?
Hi, Andy. This is Komal from the product management team. I have a question about the podcast. I was going through the podcasts that you have done in the recent past. I believe this would be the first one for ADC, right?
Yeah. Let's see. I know we've done SD-WAN. Bill, have we done anything specific around ADC? I swear, I feel like we have to have that by now, but do you remember?
I don't recall. I would think we would have as well, but I don't recall off the top of my head.
I think we obviously did when there was the exploit that had come out. We jumped on one of those, but I don't think we've done one in terms of product features, but we definitely need to. That's for sure.
Yeah. Okay, so I'm just going through the list of the podcast, and I think for pure ADC use cases, I couldn't find one till October 15th, 2019. So maybe in this podcast we can have a quick introduction for the ADC itself. Would that make sense?
Yeah, no, let's regroup and add some more of these into the mix. Bill and I are up for doing these multiple times a week. Yeah. Hey guys, but to kind of wrap up this one, I guess any additional comments from the Citrix team around this specific blog?
And that's all I had.
Yep. That was very well written. Very good job.
Yep. Chris, Bill, any additional things you'd want to bring up along this topic? Somewhat specific?
Just one more point. Probably the listeners of podcast can look into our documentation page as to what other features we have along with this offering. So please visit the documentation page as well for detailed write-up on this feature. The link is given in the blog.
Great.
Okay, great, guys. All right, well, I guess with that, we'll wrap it up. Again, Chris, Bill, any additional comments?
Nothing from me.
No, sir. Not at this time. Thanks, guys, for being here.
Hey, Chris, I guess we'd be remiss if we didn't bring up your training series you have going on. When's your next ADC training that we're doing online, which is free to anybody who wants to join?
Yeah, so we can always go to XenTegra.com/events, and on that page you can see the currently solidified and scheduled events that we're having for the ADC platforms. So we're looking at we're working on the 21st of next month for the ADC again. So those seats fill up pretty quick. So if you haven't already registered, please go ahead and get that in so we can confirm your seats.
Okay, great. And we do those every month. So
every month. And we'll do SD-WAN on a quarterly basis, cranking up on June 11th. We'll start those back up.
So if you're looking to do more with your Citrix investment, or you're looking to make applications perform better like we've talked about here today, that's definitely a great way to learn what you can do. So guys, I guess with that, we'll wrap this one up. I appreciate everybody joining. It was very informative for me. It's not an area I spend a lot of time in. However, it is a big part of the Citrix story and a big part of the application story that, we're all in it for applications. No matter what we think our job is in IT, it's the application that really at the end of the day matters, the application and its data.
That's right.
All right. Well, with that, guys, we'll wrap it up. Have a great rest of your week.
Hey, thank you all for being here.
Thanks for listening to the Citrix Session with your hosts, Andy Whiteside and Bill Sutton. A special thanks to our guests. Podcast produced by Pete Downing. Head over to XenTegra.com/podcast to listen to all podcasts in this series.